36. Which set of ordered pairs represents y as a function of x? Well, you could convert all of this to a decimals and create a table, and that would work. And you'd have multiple x's. Well, you'd have one x getting multiple y's. That's what would happen. Listen, you could go through all of that, or it could go over to Desmos. And we'll show you what to do in Desmos, because Desmos, it's a lot more clear. All right. So in Desmos, we all know we can type in a function, or we can type in a simple 2 times 3 and get 6. But what I want to do here is I want to create a table. You have x and y. So let's look, we're going to flip back and forth. So let's pick the bottom. Square root of 1, negative 3. So you go square root of 1, tab over negative 3. All right, my voice is starting to go. So let's finish the rest. Square root of 2 and negative 4. So we got square root of 2. Was it 4 or negative 4? It was negative 4. Down over. Here we have square root of 1 and negative 5. So we have the square root of 1. Then we have negative 5. Oops, we don't want to put the negative 5 there. We'll go to the next. There we are. We'll put it there. Okay, last number in that series, square root of 6 and negative 7. So we got square root of 6, and then we've got negative 7. All right, I'm going to zoom in on this so it's easier to see. Because there's a dead giveaway here. If you'll notice, for this x value, you have, okay, so I wonder if we could change the colors. No, that's okay. All right. So we can see this group down here in the below the x-axis. If you'll notice, we have two ordered pairs on the same x. That gives two different y values. That means for this x value, there are two different y values. So that is not a function. And then is the blue. We see we have more than one y value for this x, because these are all above this point on the x-axis. However, because there's an ordered pair here, there's one y value there. When we go up to the next, there's a different y value. So there's more than one y value for each x. So that's not a function, right? Turn those dots off. Now let's look at the correct answer. there's only one y value for this particular x value because we only have one ordered pair above that position on the x-axis. We go to the next, we're at a different place on the x-axis. We go to the next one, a different place, different place. There's only one ordered pair above or below this position on the x-axis. And it's the same for the rest in that series of numbers. So visually, that's what it looks like. However, if you didn't want to go through all that, what you would do is you would look for the same x value. And if there were two different y values, you would know. So here's, well, actually, you know what? I think I'm going to highlight. I'm going to highlight in red. There's a square root of 1. There's a square root of 1. But if you notice, here we have a -3. And there's a -5. So for the x value, square root of 1, there are two y values. So J is not right. Let's go to F. And same deal. Here's a x value of 1. There's an x value of 1. But they have two different y values. Square root of 3 here, square root of 10 there. So because we have more than one output for the same input, it's not a function. Does not represent a function. We can see the same thing again here on G. -15, -15, different y values. So let's look at H. 11.1, 5.1, 12.1, 6.1. It may not be linear, but it is a function. And so H is the correct answer. Okay, let's check. And indeed, H is the right answer. There you have it.